Okay, since we're going to go over some geometric means type problems, and it looks like a centroid one as well. All right, so 15 here. We have this right triangle. First off, we should see this as 6, 8, 10 Pythagorean triple. So this length here is 10. Okay, so if AD is x, then we know this has to be 10 minus x. Okay. Remember, this is the setup of geometric means, three similar triangles. Remember, the means are the three segments that are not on the long hypotenuse. The extremes are the three segments that are on the long hypotenuse. So the three extremes are x, 10 minus x, and 10. Okay. So we know, so what's the length of AD? So that means they want that piece right there. Well, if I use this one right here, call that y, then I have too many unknowns. But I can get AD from this mean, okay, which then is touching that extreme and the 10. So 6 and 6 equals x and 10. So we got 36 equals 10x, and therefore x equals 3.6. Okay. Number 18. Whenever we see this, we should be seeing this as a centroid. Three medians where the medians intersect. Remember, median goes to the midpoint from a vertex, in this case R, to the midpoint of the opposite side. So you know those are congruent. This is congruent to this, and that is congruent to this. We also know that the longer piece is double the shorter piece. The ratio is 2 to 1. Okay, so it'd be a total of 3 parts for RL. Which statement must always be true? 3 times MC. Okay, so we're talking about MC, so this is a shorter one, so X, this is going to be 2X. 3 times MC equals SC. Okay, well, SC is the whole thing, right? That's 3X. 3 times X is 3X, so that is true. So let's look at these other ones here. RM, that's 2X, equals 2 times MC. No, it's 2 times ML. MC itself equals 1/3 of SM. No, it's 1/2. This is X, and SM is 2X, so it'll be 1/2 of SM. And SM equals KM. No, that would only be true if it's an equilateral triangle. That's the only time. So it does not have to be true. Number 1 is true. All right, here we have another one. It says find, or for which angle in the figure is the sine equal to 1/2? Okay, so you gotta remember sine equals opposite over hypotenuse. Okay, so I want opposite. That angle would be 3/6. Opposite 3/6. So the sine of angle JMK or KMJ. JMK is right there. So there's one. We go to this other triangle here. It would be the opposite over the hypotenuse there, 3/6 So that'd be angle L. So we look for LJLM. Yes, that one right there. Okay. And then we look at the big one. Okay. If there's one, that's a sign of 1/2, and there's got to be 3 because all the triangles are similar. So that means their sign is going to be 1/2. So we did the small one already. We did the medium one. So now we have to look at the big triangle right here. And which one? Notice the hypotenuse is 12. Okay. And so we would have this one again. This one is opposite. 6/12 is 1/2. Okay. So those two, okay. That would be it because we have a overlapping one right there. Okay, so all these other ones would not work. Okay, so that's that. If it wasn't for that overlapping that had the same one, there would have been 3. Okay, line segment CD is the altitude drawn to the hypotenuse. EF and a right triangle ECF. CD is the altitude. CD is the altitude drawn to the hypotenuse of ECF. So CD. If EC equals 10 and EF equals 24, okay, then to the nearest tenth, what does ED equal? Okay, again, we'd have this one is my mean, so it goes in the mean spot. And this one, X, and the whole length, 24. So I have 24X equals 100. And so divided by 24. Okay, that's going to be 4.2. Because 4 times 24 is 96, so it's just past 4, and the only one just past 4 is number 1. I don't even need a calculator. Okay, next. CD is the altitude drawn. Explain why. Triangle ABC. It's ABC, the big one, is similar to ACD. Okay. So how we know that? So ACD, this one right here. What do we know it's similar? Okay, it's gonna be from AA similarity. But they both have right angles in it. There's one, and then don't forget, they both have that angle in common, angle A. Angle A is there, and angle A is the big one, ABC. So AA similarity. Okay, that's how you'd explain that. Remember the 3 ways of proving triangles similar: AA, SAS, and SSS. Remember the S's must have the same ratio. Gotta make this a little smaller so we can see it. Okay, in the diagram below, ABC is similar. So that means the corresponding angles are congruent. C matches up with G. So that means this angle is congruent to this angle. Determine the value of X, which is them equal to each other. So move that across, and X equals 20. Okay, nice and easy. Okay, I think this is the last one, yes. Okay. In the diagram below, right triangle SCV, altitude again right there. If AB is 36, AC is 12, what's the length of AD? Okay, call it X. Remember the 2 that touch right there are the X and the 36. So we have 12 and 12 for the means, and the extremes are going to be X and 36. So I have 12 times 12 equals 36X. Okay, so I'm going to divide by 36 on both sides. 12 goes into 36 3 times, and 12 divided by 3 is 4. So the answer is 4. Notice I didn't need a calculator. Okay, so left as 12 times 12. In the diagram below, RST is a 3, 4, 5 Pythagorean triple, of course, right there. Okay, altitude H, to the hypotenuse, determine the length of H. So we want that length right there. Okay. So, I can, first off, I can't use h squared equals x and 5 minus x because it's two variables. So I need to use, for example, that one first and get what a is. Okay, so I know then that's 4, and that's 4 right there. And then this length is a, and the whole length is 5. So I have 16 equals 5a. So a equals 16 fifths, which is 3.2. So a is 3.2. The whole length is 5, so that makes b 1.8. Okay, because those two add to 5. Now I can go ahead and use that because I have those two lengths. So the mean is h, and the two extremes are the 1.8 and the 3.2. Okay, so now I have h squared equals 1.8 times 3.2. So I need to multiply that out. 16, 24, 25, and 2 is 27. Add the 2, 5, 7, 5.76. 5.76 is 24. 576 is 24 squared. So it's going to be 2.4 exactly. 2.4 squared is 5.76. So there you could be, if you knew your squares, 11 through 25 for extra credit, you would have known that. Okay. All right, that does it. Let's stop this here.